We're going to be taking a look at this lab. URL-based access control can be circumvented. I'd like to start by clearing up some misconceptions many users have regarding this lab. Let's start by reading through the lab description. This website has an unauthenticated admin panel at /admin, but a front-end system has been configured to block external access to that path. Typically, when we think about front-end, especially if you speak to a web developer, we're talking about something that happens within the user's browser. That's not what this lab guideline is talking about. There is no validation that takes place in the user's browser. The guidelines here are referring to a front-end system. So we're referring to a device on the edge of the website stack that's filtering responses as they come into the web app. Think about something like a web application firewall, for example, receives a HTTP request, decides whether that request should be rejected immediately or whether it qualifies to be sent further into the stack to what we can refer to as the backend systems, which then generate a full HTTP response. Now, when we try and access the lab, if we head to the /admin route, you can see we get this fairly truncated response from the server. And if we take a look at the solution, the point's made that the response is very plain, suggesting it may originate from a front-end system. So this is somewhat conjecture, because we can, of course, return plain responses from both front-end and back-end systems. But the idea is that if this is some kind of intermediary responder we're hitting right now, such as a web application firewall, it may be possible to bypass that somehow and have our request sent further into the app. One of the reasons why we know that this is not front-end validation in web developer terms, i.e. within the browser, is simply because if we reload this page, we don't get any JavaScript. There's no JavaScript file here, so there can be no front-end validation taking place. Now, it's true that if validation was occurring in the browser, then that constitutes a security vulnerability, because what it means is that the entire HTTP response for the admin panel is being returned from the server, and the only reason we can't see that is as a result of JavaScript within the browser. But the thing is, we can fully control that JavaScript because it's our browser. That would be an example of something that's insecure. That's not what's happening here. We are legitimately only getting an access denied response, but the point is that response is very likely from a front-end system rather than from a back-end system. So thinking about this, what is happening on that front-end system? Let's just call it a web application firewall. One possibility is that it is URL-based, but it can't fully be URL-based. Why not? Well, it wouldn't make sense if the rule in the web application firewall was anytime someone tries to hit /admin, just send back an explicit deny. No one can access /admin. Of course, that doesn't make sense because administrators need to be able to access /admin. So although it's URL based, there's probably going to be some other condition there, which is reject the request if the root is /admin and the IP address is not one of these whitelisted IP addresses, for example. But the point is, unless we have that IP, we're not going to be able to proceed further than the web application firewall. And this is where we get to the custom HTTP headers. Heading back to the lab guidelines, it says, however, the back-end application is built on a framework that supports the X original URL header. So what is the X original URL header? Well, there's no point trying to look this up on MDN web docs, for example, because this is an example of a custom HTTP header. And the truth is, HTTP headers can be any arbitrary value. We can make up fully custom HTTP headers. It's just that unless we code something in the back end that's going to respond to those custom headers, well, the custom headers are not going to do anything by default. So in some senses, this X original URL header is completely arbitrary. It's a HTTP header that someone's made up. So why do we care about a HTTP header that's made up? Well, there's two main reasons. Number one, it's good to be aware of the existence of custom HTTP headers just in case we come across a web app that's making use of custom HTTP headers. But the other reason why we might be slightly more interested specifically in the X original URL header is because some frameworks make use of this specific custom header, which means there's going to be more than one site in the wild that's making use of the X original URL header. You see, it's one thing if the header is completely arbitrary, made up by a single user for a single web app. It's not going to be that helpful. Whereas in this case, and I think it's probably specific types of PHP framework that make use of this X original URL header, but the point is there's going to be more than one web app in the wild that's making use of the X original URL header. Now, what does the X original URL header do? It overwrites the URL that's submitted as part of the HTTP request. Let's just take a look at that HTTP request. Now, I do like doing things in Burp Suite, and you can do this in Burp Suite, but generally I think of Burp Suite as something that's very powerful and a little bit overkill for small tweaks like this, which we can make in our browser. So very simple things I will do directly in Firefox. More complex things like heavy fuzzing or intruder attacks, then I will fire up Burp Suite for that. So if we right click on our request, we can choose edit and resend. We can see the full request here, and there is /admin here as part of the URL. But if we add that custom header, it's going to overwrite whichever path we provide as part of the URL. So it's really just a case of adding the X original URL header onto the request. So X original URL. And let's just choose /unknown, which we know is a route that's not going to get a response. It doesn't exist. And let's remove admin from the root, so we're not going to get rejected by the web application firewall. Now, this is an unnecessary extra step that the lab guidelines recommend we take just to experiment with the functionality here. Notice we get a 404 response back. This is despite the URL being a URL that we know is valid. It should return the home page, but if we have a look at the response, we get the not found response, because what's happening here is the back end section of the web app is taking a look at the header we sent, the X original URL, and is trying to find the /unknown. So the key idea here is when we hit the web application firewall, it's the URL path itself that is inspected, not any headers. So in this case, we're not going to get kicked back by the web application firewall because we're not visiting /admin. So where does the exploit occur here? Let's edit and resend this again. We're going to change X original URL to /admin. What's going to happen? We're going to hit the front end system, as it's called in the lab guidelines. Front end system is going to check to make sure that this route is not /admin. It sees the route is not /admin. It then sends a request further into the app. The request reaches the backend system that then takes a look at the X original URL header and says, okay, this takes priority over the actual path in the URL. I need to return the HTTP response for the route /admin. What's happened there? We've effectively bypassed that front end or web application firewall validation, and we now have access to the admin route. Let's see if it works. Let's click send. You can see we get a 200 response. And without loading that up fully, you can see we clearly have access to the admin panel. So we bypassed the validation. Now, our objective is to delete the user Carlos. If we were to check out the route, we'd see it's /admin /delete, and then we append the name of the user we want to delete as part of the query string. Taking a look at the page source, we can see it there. Hyperlink /admin /delete. Query string username equals Carlos. Now, if it seems strange to you that we have a query string to delete a user, it's good that your alarm bells are going off. We shouldn't really be using get requests to delete users. This should be a post request or a delete request. So this is a vulnerability in itself, the fact that we are performing these kind of actions with a get request rather than the more secure post or delete requests. In other words, we don't really want this data being broadcast as part of the query string here. So we know which route we're trying to hit. We know how to bypass the front end validation. Let's choose edit and resend. So instead of /admin, we're going to /admin /delete. And we actually want to append the query string as part of the original URL. So we can tag on a question mark and say username equals Carlos. We're going to bypass the web application firewall. We're going to hit the back end. The backend's going to see, actually, this user really wants /admin delete because X original URL takes priority. It then checks and still has access to, by the way, the query string, the get request parameters. So it looks at the key value pair for username, takes the value Carlos and says, okay, this must be the user that's being requested to be deleted here. And it deletes it because we've already bypassed the verification. So let's click send here. We get a 302, which is essentially indicating that it's been found, but we then get redirected to the admin panel. And of course, we can't access that directly. So we then get a 403 forbidden response. But if we head back to the main page of the lab by just deleting the path, you'll see we get the message, congratulations, you solved the lab. So some key takeaways here. You might be able to use headers to bypass validation. Another key takeaway is front end does not necessarily mean in the browser, although in most cases, if you're speaking to a web developer, I would guess it's better to use the term front end to refer to things taking place in the browser. Otherwise, you're talking a different language to your average web developer who's not going to think of a front end system as really being a back end system that's kind of on the edge of the web development stack, if that makes sense. But in this case, front end really refers to something that's filtering requests as it comes into the web app, such as a web application firewall, for example. We've also learned about custom HTTP headers. We know they can be any arbitrary value, but certain types of custom headers may appear more frequently than others because they're used by a specific framework. You'll find multiple web apps may make use of the same custom HTTP header because they're all making use of the same PHP framework, for example. Possible mitigation here, just make use of a session token like everyone else to protect the admin root. Force the admin to log in with a username and password. If you want to add some additional whitelisting on top of that, if you want to say this has to be an authenticated user, and here is the acceptable list of whitelisted IPs to lock things down even further, go ahead. You can see the lack of making use of a traditional session authentication like a username and password has allowed us to access an admin root when we really shouldn't be able to do that. So you can use this type of validation, but use it on top of the traditional username and password access. That way you're making things more secure rather than less secure, which is the whole point. All right, hope it was helpful. Thanks very much for watching. Catch you guys in the next lab.